Welcome back to the series Programming in Python, and this is session 2. In this session, we'll take a look at next couple of topics in detail. Before going into today's session topics, let's have a quick recap of what we saw in the first session. Python is an open source, high level interpreter based language that can be used for many computing solutions. An identifier is a user defined name given to a variable or a constant in a program. There are several data types in Python. We saw so many of them, just a few listed here. Data type conversion can happen either explicitly or implicitly. Explicitly meaning done by the programmer, implicitly done by the Python interpreter. An expression is a combination of values, variables, and operators. Python uses input function for taking user input and print function to output data to a standard output device. The process of identifying and removing errors from a computer program is called debugging. And there are a few others like Python is case sensitive, and so on. Let's look at the list of topics once again. Getting started, we completed this in the last session. And this session, we'll be looking at flow of control first, functions afterwards, and the rest of the topics in next videos. So what is flow of control? We know that Python is interpreter based, meaning it executes statements in a sequence one at a time. Given a list of statements, it executes first, second, third, and so on. In this setup, how do we make sure, or how do we let the Python program take different paths, execute something, come back with the results, and proceed further? Flow of control. It's an order of execution of program statements. So where do we start? What kind of statements we have? How do we proceed one after other? And then how the control transfers to another set of programs or a program or block and comes back to the main program. The flow of control is implemented using control structures. One is selection, deciding to select one from two or more possible options. This is done with an if-else construct. The next is repetition. It's a repetition of a set of statements. It's also called iteration. This is done through two kinds of constructs, looping constructs. One is for and the other is while loop. We have to make a quick note of indentation here. Indentation is nothing but structuring the statements of a program in a particular alignment. In Python, leading spaces, white spaces, or tab are being used as indentation. Tab is the most commonly used indentation. Same indentation levels refer statements into a single block. For example, you have a statement, next statement you have a tab, and you have a set of statements at the same tab level, and then you come back to the previous level. The statements that are at the same alignment are considered to be part of a single block under the upper level. Python interpreter is very particular about these intents. Any change or any difference, it either throws an error or considers the statements to be of a different order and executes something that we don't really expect. Typically, for most of the cases, it throws an error. I'll show you an example for indentation. I'm just declaring a couple of variables, identifiers, and I'm going to have an if condition. Now, if I press enter, since we are on ideally, it automatically adds an intent. See, the cursor has moved to the right. Just printing. See, if you keep entering, if I have, if I go back and say print, throws an error, invalid syntax, because the print statement, which is, since I've kept typing and not completing the block, it's still considering the print statement to be part of the block, like the previous prints, two prints. So it's saying syntax error because it's not having the right intent. It's not following the intent of the previous ones. Let's do it again. Now it is taking the intent. I want to close the block, if block. Now if I say print, it's the value. If you look at the prints within the if condition and the print outside, we have three print statements in the if condition, and we have one print for number one and number two. The if condition did not execute and the print did. I mean, the print outside did show the output. Why is that? It's because of the condition we have given. When if number one equal to number two, print all this. Since number one is not equal to number two, it's not printing any of the print statements within the if condition. It's not printed. But when I printed the numbers outside the if condition, outside the block, it's printing. So it depends on the logic as well as the syntax. Now let's look at the control structures. First one is the selection. Selection has multiple syntax, commonly three basic syntaxes. First one is if a condition is satisfied, execute certain statements. For example, I'm declaring a variable number one with value 2. If number one is greater than 0, print the text number and the number actual numeral is positive. That's one syntax. If a condition is satisfied, execute one or more statements within that if condition. The second syntax is if a condition is satisfied, do action based on the statement or statements, else execute certain statements. Remember the constructs if, else, for, while, all of them will have a colon at the end. That's the syntax we have to remember. If you make a mistake there, it will be showing a syntax error. So the next example for the syntax 2 is number 1 equal to same number variable. If number is greater than or number 1 is greater than 0, print same statement we stopped before, else print number 1 is not positive. It's the alternate of what should be done. I mean, if a condition is satisfied, do this. If a condition is not satisfied, else do something else. The next syntax is if a condition is satisfied, execute statement or statements. Else, if you want to impose another condition, not just the else condition, just do something else. If a condition is not satisfied, you are going to impose another condition with another if. Instead of saying if condition statements, else if condition and statements, the keyword here is elif, elif. If else if a condition is satisfied, a different condition is satisfied, execute statement or statements. Again, just for the sample case, I've given another elif and statements, else. You come to the else and then close the statements. It can go on. There is no limit to this. It can go on. I mean, if you have a situation where you have to check for different conditions in the if, check this, else if, check this, else if, check one more. If you have a situation like that, you have no option but to go on like this. Here is one example. Same number 1 equal to if int of number 1 is greater than 0. Here I am imposing an integer because I want a whole number. I want a number that is non-negative. Print it is positive. Else if integer of num1 is less than or equal to, here in our main case it's 2, so it is greater than 0, it is not less than 0. If it is less than 0, int of less than 0 is satisfied, print it is negative, else print number is 0. If either of these conditions is not satisfied, else print this is the third statement. So as I said earlier, depending on the problem we are trying to solve or depending on the conditions we are trying to check, the if, elif, else will go on or grow in numbers. Next is repetition. Repetition is used where a particular condition, as long as a particular condition is satisfied. It's not about one single value being satisfied, it's about a loop, and as long as the condition is being satisfied, you keep executing those statements. So the syntax goes like this. For a variable or identifier in a sequence of values or items in range, keep executing the statements. List of statements keep executing as long as the variable is present or a condition is satisfied. For a particular value is being part of a range or sequence, keep executing those statements. That's the for loop syntax. Range is another built-in function in Python that is used to create a sequence of numbers from start to stop values. See, when we talk about a range, how do we build a range, or how do I get a range, right? This is one way of creating a range. The syntax is range, start, stop, and step. Of these parameters, start and step are not mandatory. Only the stop is mandatory, where the range stops. So default start is 0. If you don't give the start, default start is 0, and step is 1. If you want to give a step value, it should be a non-zero integer number. Here is an example. Remember the stop value, when you give a stop value, the sequence stops at the stop value -1. Here is an example for the for loop condition or construct. I have a sequence of numbers 1 to 10 for n in nums, meaning if the variable n is present in nums, and I have since it's a for loop, I have some conditions. If n modulus 2, remember modulus gives you the remainder. If the remainder divided by 2 remainder is 0, which is an even number, print n as an even number. Here I want to give an example for range. List of range, start is 0. We don't have to give it, but just for the sake of parameters, I have given that. The stop is 100. That is from 0 to 100. Step the values by 10 and give me the list. That's the objective here. List of range function is going to give me start numbers from 0 to 100, stepping up by 10, and create a list out of it. The next repetition construct is the while loop. Here is the syntax for the while loop. While a particular condition is being satisfied, execute the statements repeatedly that is given in the body of the while loop. Remember, in the for loop, we want a value of the variable to be satisfied or being present in a list of values. Here, it's a condition that is to be satisfied. As long as the condition is satisfied, the statements in the body of while loop will be executed repeatedly. One example to print the number, count is equal to 1 to start with. I'm initiating a variable with the value of 1, what we call declaring as well as instantiating. While count is less than or equal to 3, print count and increment count by 1. Here the count plus 1 is equivalent to count equal to count plus 1. Remember the operator, right? Plus equal to operator that assigns the value of the sum into the same variable or identifier. The output will be, first one, since it's 1 and which is satisfying the condition of less than or equal to 3, printing count 1, and I'm incrementing count value to 2 by executing the operator plus equal to. So the next one will be 2. Since it's still satisfying the less than or equal to 3, it is going to execute, and I'm incrementing that 2 to 3 by adding 1. It is still satisfying less than or equal to 3, so it's going to print again. The next one will be 4, which is not less than or equal to 3, The while loop stops executing and comes out of it, comes back to the main program. While running for or while loops, there could be situations or scenarios where we want to break out of the loop, stop the loop completely, or skip the value we are processing and proceed further. Break and continue help us do that. Break is used when there is a need to stop the execution and come out of the loop completely. Python resumes the execution from the statement after the loop. Here is an example for break. I'm defining number with 0 value. For num in range 0, 10, 2, that is start value of 0, stop value of 10 with step value of 2, meaning I have a list of 0, 2, 4, 6, and 8. And I'm incrementing the number to be number plus 2. And I'm printing the value, current value. And when I reach number equal to 6, print number is string of num. At this point, it will be 6. Break applied, exit from loop with the break statement. I show this on the IDLE, Python IDLE. Since there are quite a few statements, I've stored the statements into a Python file. I'm opening that and we'll execute from there. So here are the statements, same as an example. I'm running them and I'm getting the results like this. I have 246, that is from the list. Since I'm incrementing the initial value of 0 before even executing the print statement. The moment the if condition number equal to 6 is encountered, it is printing the number is 6 and break applied exit from loop. That's how the break statement works. The next one is the continue statement. Continue statement is used to skip remaining statements of the loop and go back to the next value in the iteration. It's not completely coming out of the loop. It is just skipping that particular condition or the value and goes back to the loop to execute the next iteration of the loop. Here is an example. Similar set of instruction like the break statement, only that it uses continue and a different set of print statements. Here, same number range 0 as a start, 10 as a stop, 2 step. So you will have 2, 0, 2, 4, 6, and 8 as range values or list values. Number being incremented by 2. When it encounters 6, I'm saying continue instead of break in the previous example. What happens is when the number 6 is encountered, it doesn't do any operation or whatever operation we have expected to and goes back to the next number in the list. I'll show it in the ideally now. I'll open the sample file created for the continue statement. And here we have the same statements as given in the presentation. I'm going to run it in the run module. So as you can see, it's printing number 2, 4, 8 and 10. Because when it encountered number 6, we asked not to print or not to do any action over there, just ask it to continue, meaning skip the value and go back to the next value, which is 8 in this particular example. Moving on, nested loops. Nested loops are nothing but loops being called within the loops. There is no limit on loops in a loop. It can be any number. And the loop type is not a problem for usage across. A for loop can go into a while loop and while loop can go into a for loop. Here is an example. In this example, I'm going to find out the prime numbers between number 2 and 20. I'm instantiating j as a variable with value 2, while j, the while condition, as long as the while condition j less than or equal to I divided by 2 is being satisfied. If the modulus of I divided by j equal to 0, which means there is no remainder, which means it's not a prime number. Break and increment j with 1. If j is greater than I by j, then print I is a prime number. We'll go to the IDLE. I'm opening the sample file created for nested loops. and run it. So between 2 and 20, these are all the prime numbers. In this example, we have a while loop within the for loop. And as we mentioned earlier, a for loop can go inside a while loop or a while loop can go inside a for loop. There is no constraint. So a recap of what is flow of control. The if statement is used for selection or decision making. The looping constructs while and for allows sections of code to be executed repeatedly under some condition. While loop as long as the condition is satisfied. For loop as long as the value is part of a sequence or a range. For statement reiterates for a range of values or a sequence. Statements within the body of loop are executed till the range of values is exhausted. The statements within the body of a while are executed repeatedly until the condition of the while becomes false. The condition should become false at some point, else the loop will go on infinite. When we write the while loop, we have to ensure the condition becomes false at some point in time. As I mentioned, if it is not becoming false, it's always yes or true, it will never stop and we'll never come out of the loop and the program will never end. The break statement immediately exits the loop, skipping the rest of the loop's body. Execution resumes from the statement next to the loop block. Whereas a continuous statement is encountered, the control jumps to the beginning of the loop for the next iteration. A loop within another loop is called a nested loop.